The servlet model. Servlets. In the Java world, servlets are the cornerstone of web component technology. In this part of the book, we discuss aspects of the servlet technology that you need to know, as specified by the exam objectives. Exam objectives. 1. One for each of the HTTP methods such as get, post, head, and so on. Describe the purpose of the method and the technical characteristics of the HTTP method protocol. List triggers that might cause a client, usually a web browser, to use the method. And identify the HttpServlet method that corresponds to the HTTP method. Sections 4. 1 and 4. 2. 1. 2. Using the HttpServlet request interface, write code to retrieve HTML form parameters from the request, retrieve HTML request header information, or retrieve cookies from the request section 4. 3. 1. 3. Using the HttpServletResponse interface, write code to set up an HTTP response header, set the content type of the response, acquire a text stream for the response, acquire a binary stream for the response, redirect an HTTP request to another URL, or add cookies to the response section 4. 4. 1. 4. Describe the purpose and event sequence of the servlet lifecycle. Servlet class loading, servlet instantiation, call the init method, call the service method, and call the destroy method section 4. 5. 3. 5. Describe the request dispatcher mechanism. Write servlet code to create a request dispatcher. Write servlet code to forward or include the target resource, and identify and describe the additional request scoped attributes provided by the container to the target resource. Section 4. 8. Introduction. Java servlet technology is commonly used to handle the business logic of a web application, although servlets may also contain presentation logic. We discussed the basics of Java servlets in Chapter 1. In this chapter, we will take a closer look at the servlet model. The servlet specification applies to any protocol, but in practice, most servlets are written for the HTTP protocol, which is why the SCWCD exam focuses on HTTP servlets. In this context, whenever we talk about servlets, we mean HTTP servlets. Similarly, by client and server, we mean HTTP client and HTTP server, respectively. This chapter is lengthy, and while it introduces many concepts about servlets, it will not provide in-depth discussions. Don't worry. At this point, we want you to get familiar with the servlet model without getting lost in the details. We will cover all of these concepts in detail in later chapters. 4. 1. Sending requests, web browsers and HTTP methods. As we discussed in Chapter 3, the HTTP protocol consists of requests from the client to the server, and the responses from the server back to the client. Let's look at the request first. A web browser sends an HTTP request to a web server when any of the following events happen. A user clicks on a hyperlink displayed in an HTML page. A user fills out a form in an HTML page and submits it. A user enters a URL in the browser's address field and presses enter. Other events trigger a browser to send a request to a web server. For instance, a JavaScript function may call the reload method on the current document. Ultimately, however, all such triggers boil down to one of the 3 events listed above, because such method calls are nothing but programmatic simulations of the user's actions. By default, the browser uses the HTTP GET method in all of the above events. However, we can customize the browser's behavior to use different HTTP methods. For example, the following HTML form forces the browser to use the HTTP post method via the method attribute. Form name equal login form method equal post action equal login servlet. Input type equal text name equal insert. Input type equal password name equal PASSWD. Input type equal submit name equal login button value equal login. Form. Note if you do not specify the method attribute in a form tag, the browser uses get by default. If you require a post, you must explicitly specify method equal post in the form tag. In the following section, we will look at situations in which we might need to force the browser to use post instead of get. 4. 1. Comparing HTTP methods. For the exam, you will be required to demonstrate that you understand both the benefits and functionality of these HTTP methods. Get post head. We have already seen their basic structure and meaning in Chapter 3. Now we will look at the difference between their uses, and identify the situations in which one method is preferred over the other. Table 4. 1 compares the features of get and post. Table 4. 1 comparison of get and post methods. Based on Table 4. 1. We can make some generalizations about when to use each method. Use get to retrieve an HTML file or an image file, because only the file name needs to be sent. Use post to send a lot of data. For example, post is well suited for an online survey, since the length of the query string may exceed 255 characters to upload a file. To capture the username and password, because we want to prevent users from seeing the password as a part of the URL. Recall from Chapter 3 that head is the same as get except that for a head request, the server returns only the response header and not the message body. This makes head more efficient than get in cases where we need only the response header. For example, a response header contains the modification timestamp, which can be used to determine the staleness of a resource. In general, clicking on a hyperlink or using the browser's address field causes the browser to send a get request. We can, of course, attach a JavaScript function, onClick, to programmatically submit a form, thereby causing a post request to be sent. However, that is not what we are concerned about for the purpose of the exam. Quizlet. Q. A developer wants to upload a file from the browser to the server. The following is the HTML snippet from the HTML page that she wrote. Form name equal uploader action equal. Save servlet type equal multipart. Form data. Input type equal file name equal file. Input type equal submit name equal upload button value equal upload form. What is wrong with this code snippet? A. The contents of the file must be sent to the server using a post request. However, the HTML form used in this code does not have any method attribute. Therefore, a get request will be sent. The developer must specify the form tag like this. Form name equal uploader action equal. Save servlet type equal multipart. Form data method equal post. 4. 2 Handling HTTP requests in an HttpServlet. In the previous section, we discussed 3 commonly used HTTP methods, their features and limitations, and the situations in which these methods are used. In this section, we will explore what happens when an HTTP request reaches an HTTP servlet. For every HTTP method, there is a corresponding method in the HttpServlet class having the general signature protected void doXXX HttpServletRequest. HttpServletResponse throws servlet exception, exception, where doXXX depends on the HTTP method, as shown in Table 4. 2. Table 4. 2 HTTP methods and the corresponding servlet methods. The HttpServlet class provides empty implementations for each of the doXXX methods. We should override the doXXX methods to implement our business logic. Understanding the sequence of events in HttpServlet. You may now wonder who calls the doXXX methods. Here is the flow of control from the servlet container to the doXXX methods of a servlet. 1. The servlet container calls the ServletRequest, ServletResponse method of HttpServlet. 2. The ServletRequest, ServletResponse method of HttpServlet calls the HttpServletRequest, HttpServletResponse method of the same class. Observe that the service method is overloaded in the HttpServlet class. 3. The service HttpServletRequest, HttpServletResponse method of HttpServlet analyzes the request and finds out which HTTP method is being used. Depending on the HTTP method, it calls the corresponding doXXX method of the servlet. For example, if the request uses the post method, it calls the doPost method of the servlet. Note, if you override the service methods in your servlet class, you will lose the functionality provided by the HttpServlet class, and the doXXX methods will not be called automatically. In your implementation, you will have to determine the HTTP method used in the request, and then you will have to call the appropriate doXXX method yourself. For this reason, it's recommended to only override the doPost or doGet methods. All of the doXXX methods take two parameters: an HttpServletRequest object and an HttpServletResponse object. We will learn about these objects in the following sections. But first, here's a note about the Servlet API. Most of the important components of the Servlet API, including HttpServletRequest and HttpServletResponse, are interfaces. The servlet container provides the classes that implement these interfaces. So, whenever we say something like an HttpServletRequest object, we mean an object of a class that implements the HttpServletRequest interface. The name of the actual class is not significant and is, in fact, unknown to the developer. Quizlet. Q. Which method of TestServlet will be called when a user clicks on the following URL? A ref equal servlet. TestServlet method equal post. Test URL. The method equal post attribute value pair does not make sense in the a ref tag. Clicking on a hyperlink always sends a GET request, and thus, the doGet method of the servlet will be called. 4. 3. Analyzing the request. Both ServletRequest and its subclass, HttpServletRequest, allow us to analyze a request. They provide us with a view of the data sent by the browser. The data includes parameters, meta information, and a text or binary data stream. ServletRequest provides methods that are relevant to any protocol, while HttpServletRequest extends ServletRequest and adds methods specific to HTTP. It is for this reason that the ServletRequest interface belongs to the javax. Servlet package in the HttpServletRequest interface belongs to the javax. Servlet HTTP package. We always use the HttpServletRequest class, but it is important to know which methods are implemented in the HttpServletRequest class and which methods are inherited from the ServletRequest class. 4. 3. 1. Understanding ServletRequest. The primary use of ServletRequest is to retrieve the parameters sent by a client. Table 4. 3 describes the methods provided to retrieve the parameters. Table 4. 3 methods provided by ServletRequest for retrieving client-sent parameters. String getParameter string ParameterName. This method returns just one of the values associated with the given parameter. String getParameterValues string ParameterName. This method returns all the values associated with the parameter. For example, while doing a job search, you might have seen a location list box that allows you to select multiple states. In this case, the parameter location may have multiple values. Enumeration getParameterNames. This method is useful when you don't know the names of the parameters. You can iterate through the enumeration of strings returned by this method, and for each element you can call getParameter or getParameterValues. 4. 3. 2. Understanding HttpServletRequest. The class that implements the HttpServletRequest interface implements all of the methods of ServletRequest in an HTTP-specific manner. It parses and interprets HTTP messages and provides the relevant information to the servlet. Let's look at an example of how we can use these methods. Figure 4. 1 shows an HTML page that allows the user to send 2 parameters to the server. Figure 4. 1. An HTML page containing a form listing 4. 1 is the HTML code for this page. Listing 4. 1 HTML page snippet. Form action equal Servlet. TestServlet method equal post. Technology. Input type equal text name equal searchstring value equal Java. BR. State. Select name equal state size equal 5 multiple. Option value equal NJ. New Jersey. Option value equal NY. New York. Option value equal KS. Kansas. Option value equal CA. California. Option value equal TX. Texas. Option select BR. Input type equal submit value equal search job. Form. This form displays a text field, a list box, and a submit button. The action attribute of the form specifies that TestServlet should handle the request. Observe that the method attribute of the form is set to post, and so the parameters will be sent to the server using an HTTP post request. Once the request is sent to the server, TestServlet is invoked. Listing 4. 2 shows how TestServlet's doPost method retrieves the parameters that were sent by submitting the form listing 4. 1. Listing 4. 2 code for doPost to retrieve parameter values public void doPost HttpServletRequest rec HttpServletResponse restring searchstring equal rec getParameter searchstring string statelist equal rec getParameterValues state. Use the values and generate appropriate response. In the above code, we know the names of the parameter searchstring and state sent with the request, so we can use the getParameter and getParameterValues methods to retrieve the parameter values. When the parameter values are not known, we can use getParameterNames to retrieve the parameter names. Retrieving request headers. Just as there are methods to retrieve request parameters, there are methods to retrieve names and values from request headers. We'd like to point out one difference, though. Unlike parameters, headers are specific to the HTTP protocol, and so the methods that deal with the headers belong to HttpServletRequest and not to ServletRequest. HttpServletRequest provides the methods shown in Table 4. 4 to help us retrieve the header information. Table 4. 4 HttpServletRequest methods for managing request headers. String getHeader string header name. This method returns just one of the values associated with the given header. Enumeration getHeader string header name. This method returns all the values associated with the header as an enumeration of string objects. Enumeration getHeader names. This method is useful when you don't know the names of the headers. You can iterate through the enumeration returned by this method, and for each element you can call getHeader or getHeaders. Let's see how we can use the methods described in Table 4. 4. The service method code shown in Listing 4. 3 prints out all the headers present in a request. Listing 4. 3 printing out all the headers on the console. Public void service HttpServletRequest rec HttpServletResponse res enumeration headers equal rec getHeader names. While headers has more elements, string header equals string headers. Next element string value equal rec getHeader header. System out print on header plus equal plus value. The final HttpServletRequest method that you'll need to know for the exam is getCookies. This method returns an array of cookie objects that provide information about the current client. Server interaction called a session. We'll discuss these objects and their uses in Chapter 8. There are other convenience methods in ServletRequest and an HttpServletRequest that we will not discuss here, since they are not required for the exam. To learn more about them, refer to the Servlet API documentation. Quizlet. Q. Which method would you use to retrieve the number of parameters present in a request? A. Neither ServletRequest nor HttpServletRequest provides any method to retrieve the number of parameters directly. You'll have to use ServletRequest. getParameterNames, which returns an enumeration, and count the number of parameters yourself. 4. For sending the response. The HttpServletResponse object is a servlet's gateway to send information back to the browser. It accepts the data that the servlet wants to send to the client and formats it into an HTTP message as per the HTTP specification. ServletResponse provides methods that are relevant to any protocol, while HttpServletResponse extends ServletResponse and adds HTTP-specific methods. Not surprisingly, the ServletResponse interface belongs to the javax. Servlet package in the HttpServletResponse interface belongs to the javax. Servlet HTTP package. 4. 1. Understanding ServletResponse. ServletResponse declares several generic methods, including getWriter, getOutputStream, setContentType, and so forth. We will now discuss two important methods. Using PrintWriter. Let's first look at the getWriter method of ServletResponse. This method returns an object of class Java. PrintWriter that can be used to send character data to the client. PrintWriter is extensively used by servlets to generate HTML pages dynamically. Listing 4 demonstrates its use by sending the header information of a request to the browser. Listing 4 writing HTML code dynamically. Import Java. Import Java. Util. Import javax. Servlet. Import javax. Servlet. HTTP. Public class show header servlet extends HttpServlet. Public void do get HttpServletRequest HttpServletResponse res throws servlet exception, exception PrintWriter PW equal res. getWriter. PW. Println. HTML. PW. Println. Head. PW. Println. Head. PW. Println. Body. PW. Println. H3. Following are the headers that the server received. H3. P. Enumeration headers equal rec. Get header names. While headers has more elements, string header equals string headers. Next element. String value equal rec. Get header header. PW. Print on header plus equal plus value plus. BR. PW. Println. Body. PW. Println. HTML. In listing 4, we use the getWriter method to retrieve the PrintWriter object. We use the getHeaderNames and getHeader methods to retrieve header information, and then we write the values using the PrintWriter object. We then finish our dynamic HTML page with a closing body and HTML tag using ServletOutputStream. If we want to send a binary file, for example a jar file, to the client, we will need an output stream instead of a PrintWriter. ServletResponse provides the getOutputStream method that returns an object of class javax. Servlet OutputStream. In listing 4, we have changed the doGet method of the previous example to send a jar file to the browser. Listing 4, sending a jar file to the browser. Public void doGet HttpServletRequest HttpServletResponse res throws servlet exception, exception res. SetContentType application. Jar. File Fahrenheit equal new file test. Jar. Byte bacteria equal new byte int f. Length. File input stream is equal new file input stream f. Is. Read bacteria. Output stream os equal res. Get output stream. Os. Write bacteria. Os. Flush. In listing 4, we retrieve the output stream using the getOutputStream method. We simply read the contents of a jar file into a byte array and write the byte array to the output stream. Observe that we are calling the setContentType method before calling the getOutputStream method. The setContentType method allows us to specify the MIME type of the data we are sending in the response. The content type can also include the character encoding used in the response. If we need to obtain a PrintWriter with a non-default content type or character encoding, we must call setContentType before calling getWriter. The setContentType method belongs to the ServletResponse interface and is declared as shown in Table 4. 5. Table 4. 5. The method provided by ServletResponse for setting the content type of the response. Public void setContentType string type. This method is used to set the content type of the response. The content type may include the type of character encoding used, for example, text. HTML charset equal ISO 8859-4. If obtaining a PrintWriter, this method should be called first for the charset to take effect. If this method is not called, the content type is assumed to be text. HTML. The following are some commonly used values for the content type. Text. HTML, image. JPEG, video. QuickTime, application. Java, text. CSS, and text. JavaScript. You might have also noticed that in the line file Fahrenheit equal new file test.jar. We are hard-coding the filename to test.jar. This requires the file test.jar to be in the bin directory of Tomcat. We will come back to this later in section 4. 7. To learn a better way of specifying the file. Note: an important point to note about the getWriter and getOutputStream methods is that you can call only one of them on an instance of ServletResponse. For example, if you have already called the getWriter method on a ServletResponse object, you cannot call the getOutputStream method on the same ServletResponse object. If you do, the getOutputStream method will throw an illegal state exception. You can call the same method multiple times, though. Sends the bytes of the byte array to the browser, flushes the data. 4. 2. Understanding HttpServletResponse. In addition to setting the content type of the response, there are 3 other important capabilities of HttpServletResponses that you need to know for the exam. Setting response header information, redirecting HTTP requests to another URL, and adding cookies to the response. Setting the response headers. We use headers to convey additional information about the response by setting name-value pairs. For example, we can use a header to tell the browser to reload the page it is displaying every 5 minutes, or to specify how long the browser can cache the page. As shown in Table 4. 6. The HttpServletResponse interface provides 7 methods for header management. Table 4. 6 HttpServletResponse methods for managing response headers. Void set header string name, string value. Used to set the name value pair for a header in the servlet request. Void set and header string name, in value. Saves you from converting the in value to string. Void set date header string name, long mib6. Pretty much the same as above. Void addHeader. Add in header. Add date header. These methods can be used to associate multiple values with the same header. Boolean contains header string name. Returns a boolean that tells you whether or not a header with this name is already set. Table 4. 7 shows for important header names. Although on the exam you will not be asked questions based on header names and values, it is good to know some commonly used headers. Table 4. 7 typical response header names and their uses. For a complete list of header names values, refer to the HTTP specification. Another useful method related to headers is addCookie. This method lets us create cookie objects and set them in the response. We will learn about cookies in Chapter 8, Session Management. Redirecting the request. After analyzing a request, a servlet may decide that it needs to redirect the browser to another resource. For example, a company website may be able to provide only company news. For all other kind of news, it may redirect the browser to another website. The HttpServletResponse class provides the sendRedirect method exactly for this purpose. as shown here. If company news equals request, get parameter news category, retrieve internal company news and generate the page dynamically, else response. Send redirect HTTP CNN com. The above code checks the news category parameter to decide whether it should generate a reply on its own or redirect the browser to CNN com. When the browser receives the redirect message, it automatically goes to the given URL. We should keep in mind a couple of important points about the send redirect method. We cannot call this method if the response is committed, that is, if the response header has already been sent to the browser. If we do, the method will throw a java.lang, a legal state exception. For example, the following code will generate an illegal state exception. Public void do get HttpServletRequest rec, HttpServletResponse res PrintWriter pw equal res, getWriter, pw, println, HTML, body, hello world, body, HTML, pw, flush, res, send redirect HTTP, CNN, com. In this code, we are forcing the servlet container to send the header and the generated text to the browser immediately by calling pw, flush. The response is said to be committed at this point. Calling send redirect after committing the response causes the servlet container to throw an illegal state exception. Note another important point to understand about send redirect is that the browser goes to the second resource only after it receives the redirect message from the first resource. In that sense, send redirect is not transparent to the browser. In other words, the servlet sends a message telling the browser to get the resource from elsewhere, sending status codes for error conditions. HTTP defines status codes for common error conditions such as resource not found, resource moved permanently, and unauthorized access. All such codes are defined in the HttpServletResponse interface as constants. HttpServletResponse also provides send error in status code and send error in status code, string message methods that send a status code to the client. For example, if a servlet finds out that the client should not have access to its output, it may call response. Send error HttpServletResponse. SE unauthorized. When the browser receives this status code, it displays an appropriate message to the user. For a complete list of status codes, refer to the API documentation on HttpServletResponse. Quizlet. Q. Which methods should you use to do the following? 1. Write HTML tags to the output. 2. Specify that the content of the response is a binary file. 3. Send a binary file to the browser. 4. Add a header to a response. 5. Redirect the browser to another resource. A. 1. First, get the PrintWriter using ServletResponse. GetWriter and then call PrintWriter. Print HTML tags. 2. Use ServletResponse. Set content type string content type. 3. Use ServletResponse. GetOutputStream. And then OutputStream. Write bytes. 4. Use HttpServletResponse. Set header name, value. 5. Use HttpServletResponse. Send redirect string URL string. 4. 5. Servlet lifecycle. By now, it should be very clear that a servlet receives a request, processes it, and sends a response back using the doXXX methods. There is, however, a little bit more to understand than just the doXXX methods. Before a servlet can service the client requests, a servlet container must take certain steps in order to bring the servlet to a state in which it is ready to service the requests. The first step is loading and instantiating the servlet class. The servlet is now considered to be in the loaded state. The second step is initializing the servlet instance. Once the servlet is in the initialized state, the container can invoke its service method whenever it receives a request from the client. There may be times when the container will call the destroy method on the servlet instance to put it in the destroyed state. Finally, When the servlet container shuts down, it must unload the servlet instance. Figure 4.2 shows the servlet states and their transitions. Figure 4.2 servlet state transition diagram. These states constitute the life cycle of a servlet. Let's take a closer look at them. 4.5. 1. Loading and instantiating a servlet. When we start up a servlet container, it looks for a set of configuration files, also called the deployment descriptors, that describe all the web applications. Each web application has its own deployment descriptor file, web.xml, which includes an entry for each of the servlets it uses. An entry specifies the name of the servlet and a Java class name for the servlet. The servlet container creates an instance of the given servlet class using the method Class.forName class name. New instance. However, to do this the servlet class must have a public constructor with no arguments. Typically, we do not define any constructor in the servlet class. We let the Java compiler add a default constructor. At this time, the servlet is loaded. 4.5. To initializing a servlet. It is entirely possible that we will want to initialize the servlet with some data when it is instantiated. How can we do that if we do not define a constructor? Good question. It is exactly for this reason that once the container creates the servlet instance, it calls the initServletConfig method on its newly created instance. The ServletConfig object contains all the initialization parameters that we specify in the deployment descriptor of the web application. We will see how these parameters can be specified in the web.xml file in section 4.6. 2. The servlet is initialized after the init method returns. This process of initializing a servlet using the initialization parameters from the ServletConfig object is quite important in order to ensure the reusability of a servlet. For example, if we wanted to create a database connection in the servlet, we would not want to hard-code the username, password and the database URL in the servlet. The init method allows us to specify them in the deployment descriptor. The values in the deployment descriptor can be changed as needed without affecting the servlet code. When the servlet initializes, it can read the values in its init method and make the connection. It does not make sense to initialize an object repeatedly. Therefore, the framework guarantees that the servlet container will call the init method once and only once on a servlet instance. Note, if you look up the API for the generic servlet class, you will see that it has two init methods. One with a parameter of type ServletConfig as required by the servlet interface and one with no parameters. The no parameter init method is a convenience method that you can override in your servlet class. If you override the initServletConfig method, you will have to include a call to super initConfig in the method so that the generic servlet can store a reference to the config object for future use. To save you from doing that, the generic servlet's initServletConfig method makes a call to the generic servlet's no parameter init method, which you can implement freely. To get the ServletConfig object in the no parameter init method, you can call the getServletConfig method implemented by the generic servlet class. Pre-initializing a servlet. Usually, a servlet container does not initialize the servlets as soon as it starts up. It initializes a servlet when it receives a request for that servlet for the first time. This is called lazy loading. Although this process greatly improves the startup time of a servlet container, it has a drawback. If the servlet performs many tasks at the time of initialization, such as catching static data from a database on initialization, the client that sends the first request will have a poor response time. In many cases, this is unacceptable. The servlet specification defines the load on startup element, which can be specified in the deployment descriptor to make the servlet container load and initialize the servlet as soon as it starts up. This process of loading a servlet before any request comes in is called preloading, or pre-initializing, a servlet. 4.5. 3. Servicing client requests. After the servlet instance is properly initialized, it is ready to service client requests. When the servlet container receives requests for the servlet, it will dispatch them to the servlet instance by calling the servlet service ServletRequest, ServletResponse method. 4. 5. For destroying a servlet. If the servlet container decides that it no longer needs a servlet instance, it calls the destroy method on the servlet instance. In this method, the servlet should clean up the resources, such as database connections that it acquired in the init method. Once this method is called, the servlet instance will be out of service and the container will never call the service method on this instance. The servlet container cannot reuse this instance in any way. From this state, a servlet instance may only go to the unloaded state. Before calling the destroy method, the servlet container waits for the remaining threads that are executing the servlet's service method to finish. A servlet container may destroy a servlet if it is running low on resources and no request has arrived for a servlet in a long time. Similarly, if the servlet container maintains a pool of servlet instances, it may create and destroy the instances from time to time as required. A servlet container may also destroy a servlet if it is shutting down. 4. 5. Unloading a servlet. Once destroyed, the servlet instance may be garbage collected, in which case the servlet instance is said to be unloaded. If the servlet has been destroyed because the servlet container is shutting down, the servlet class will also be unloaded. 4. 5. 6. Servlet state transition from the servlet container's perspective. Figure 4. 3 illustrates the relationship between the servlet container and the life cycle phases of a servlet. Figure 4. 3. The servlet life cycle from the servlet container's perspective. A servlet goes from the unloaded to the loaded state when a servlet container loads the servlet class and instantiates an object of the class. The servlet container initializes the servlet object by calling its init method, thereby putting it in the initialized state. The servlet stays in the initialized state until the servlet container decides to destroy the servlet. From the initialized state, the servlet enters the servicing state whenever the servlet container calls its service method in order to process client requests. The servlet enters the destroyed state when the servlet container calls its destroy method. Finally, the servlet goes to the unloaded state when the servlet instance is garbage collected. Table 4. 8 summarizes all the servlet lifecycle methods. Table 4. 8 servlet lifecycle methods as defined in servlet interface. Void init servlet config. The servlet container calls this method to initialize the servlet. Void service ServletRequest, ServletResponse. The servlet container calls this method to service client requests. Void destroy. The servlet container calls this method when it decides to unload the servlet. Note a servlet container calls the init servlet config method on a servlet object only once. However, it is possible that it will create multiple servlet objects of the same servlet class if more than one servlet element is defined in the web.xml file having the same servlet class names. You can do this if you want to have multiple sets of initialization parameters. For example, you may want one instance to connect to one database and a second instance to connect to another database. Quizlet. Q. Which method does the servlet container call on a servlet to initialize the servlet? A. The init javax. Servlet. Servlet config method of the javax. Servlet. Servlet interface. The javax. Servlet. Generic servlet class implements this method. 4. 6. Servlet config. A closer look. We learned in the previous section that the servlet container passes a servlet config object in the init servlet config method of the servlet. In this section, we will look at the details of servlet config that you need to understand for the exam. 4. 6. 1. Servlet config methods. The servlet config interface is defined in the javax. Servlet packaging is rather simple to use. It provides 4 methods, as shown in Table 4. 9. Table 4. 9 servlet config methods for retrieving initialization parameters. String getInit parameter string name. returns the value of the parameter or null if no such parameter is available. Enumeration getInitParameterNames returns an enumeration of strings for all the parameter names. Servlet context getServletContext returns the servlet context for the servlet. String getServletName returns the servlet name as specified in the configuration file. Notice that servlet config provides methods only to retrieve parameters. You cannot add or set parameters to the servlet config object. A servlet container takes the information specified about a servlet in the deployment descriptor and wraps it into a servlet config object. This information can then be retrieved by the servlet at the time of its initialization. 4. 6. 2 example. A servlet and its deployment descriptor. To really understand the servlet config methods, you first need to understand how to specify the initialization parameters in the deployment descriptor. The web.xml file shown in listing 4.6 declares a servlet and specifies 4 initialization parameters for the servlet. Later, we will use these parameters in our servlet to make a connection to the database. Listing 4.6 The web.xml file specifying init parameters. XML version equal 1. 0 encoding equal ISO 8859-1. doc.type web app public. Sun Microsystems, Incorporated. DTD Web Application 2. 3. ENHTTP. Java. Sun. Com. J2E. DTDS. Web App 2.3. DTD. Web App. Servlet. Servlet name. TestServlet. Servlet name. Servlet class. TestServlet. Servlet class. Init param name. Driver class name. Param name. Param value. Sun. JDBC. ODBC. JDBC ODBC driver. Param value. Init param. Param name. Burl. Param name. Param value. JDBC. ODBC. Misclog. Param value. Init param. Param name. Username. Param name. Param value. TestUser. Param value. Init param. Param name. Password. Param name. Param value. Test. Param value. Init param. Load on startup. 1. Load on startup. Servlet. Web app. We will discuss the complete structure of a deployment descriptor in Chapter 5, but for now, just note that the above listing has 1. Servlet. Element, which defines a servlet named TestServlet. The servlet element has 4 init param elements, which define 4 parameters. Driver class name, burl, username, and password. Notice the load on startup element, which ensures that the servlet will be loaded as soon as the container starts up. Now we are ready to examine the servlet config methods in action. Listing 4.7 shows the complete code for the TestServlet servlet, which uses the initialization parameters we defined in the deployment descriptor. Listing 4.6 to connect to a database. Listing 4.7 TestServlet. Java. Making use of init parameters. Import Java. IO. Import Java. Util. Import Java. SQL. Import javax. Servlet. Import javax. Servlet. HTTP. Public class TestServlet extends HttpServlet connection DB connection. Public void init system. Out. Print on getServletName plus. Initializing. Servlet config equal getServletConfig. String driver class name equal config. Get parameter driver class name. String db URL equal config. Get parameter burl. String username equal config. Get parameter username. String password equal config. Get parameter password. Load the driver class. For name driver class name. Get a database connection DB connection equal driver manager. Get connection DB URL, username, password. System. Out. Println initialized. Public void service HttpServletRequest HttpServletResponse res throws servlet exception, Java. IO. IException. Get the requested data from the database and generate an HTML page. Public void destroy try DB connection. Close. Catch exception EE. Print stack trace. The above servlet reads the initialization parameters specified in the deployment descriptor and makes a connection to the database in the init method. It also uses the getServletName method to print a debug statement on the console. The getServletName method returns the name of the servlet as defined in the ServletName element of the deployment descriptor. Observe the use of the destroy method to close the connection. 4. 7. Servlet context. A closer look. We can think of the servlet context interface as a window for a servlet to view its environment. A servlet can use this interface to get information, such as initialization parameters for the web application or the servlet container's version. This interface also provides utility methods for retrieving the multi-purpose Internet Mail extension's MIME type for a file, for retrieving shared resources such as property files, for logging, and so forth. Every web application has one and only one servlet context, and it is accessible to all the active resources of that application. It is also used by the servlets to share data with one another. It is important to have a thorough understanding of servlet context, since the exam contains many questions about this interface. This book is organized according to the exam objectives, and we will discuss the various servlet context methods in different chapters as they apply to those objectives. In this section, we will work with the getResource and getResourceStream methods. These methods are used by a servlet to access any resource without worrying about where the resource actually resides. For a detailed description of these methods, you should refer to the API documentation. Table 4. 10 provides a brief description of each. Table 4. 10 servlet context methods for retrieving a resource. Java. Net. URL getResourceString path. This method returns a Java. Net. URL object for the resource that is mapped to the given path. Although the path should start with, it is not an absolute path, it is relative to the document root of this web application. For instance, if you pass a path to a JSP file, it will give you the unprocessed data, i.e. in this case, the JSP source code, when you read the contents. Java. IO. Input stream getResourceStream string path. This is a shortcut method if you just want to get an input stream out of the resource. It is equivalent to getResource path. OpenStream. If you recall from listing 4. 5, in which we sent a jar file to the browser, we had hard-coded the jar filename in the line. File Fahrenheit equal new file test. jar. The code in listing 4. 8 uses the getResource method to specify the filename independently of the file system. Listing 4. 8 making use of servlet context. getResource. Public void service HttpServletRequest HttpServletResponse res throws javax. Servlet. Servlet exception. Java. IO. IException res. setContentType application. jar. OutputStream os equal res. getOutputStream. 1K buffer byte bacteria equal new byte 1024. Servlet context equal getServlet context. URL equal context. getResource. Files. Test. jar. Input stream is equal URL. OpenStream. Int bytes read equal 0, while bytes read equal is. Read bacteria equal -1 os. Write bacteria 0, bytes read. os. Flush. Is. Close. In listing 4. 8, we have specified a relative path to the file test. jar. This allows us to deploy this servlet anywhere without worrying about the absolute location of the file. As long as test.jar is available under the web directory, files directory, it can be found. Here are the limitations of the getResource and getResourceStream methods. You cannot pass a URL of any active resource, for example, a JSP page or servlet, to this method. If used improperly, this method can become a security hole. It can read all of the files that belong to this web application, including the files under the web.inf directory of this web application. A servlet can, of course, access a resource directly by converting a relative path to an absolute path using the getRealPathString method of servlet context. However, the problem with this approach is that it is not helpful when the resource is inside a jar file. It is also useless when the servlet is running in a distributed environment where the resource may reside on a different machine. In such situations, the getResource method comes handy. 4. 8. Beyond servlet basics. Until now, we have been discussing servlets from the point of view of just one servlet. But in the real world, having just one servlet to do all the tasks is not practical. Typically, we divide the business process into multiple tasks. For example, consider a grossly simplified business process of a bank. A user should be able to return a URL object to the file, open an account, view the account balance, make deposits, make withdrawals, close the account. Besides these activities, many other business rules need to be addressed as well. For example, a user should not be able to view or withdraw from anyone else's account. We usually break up the whole business process into different tasks and have one servlet focus on one task. In the example described above, we can have a login servlet that allows the user to sign up and log in, out, and an account servlet that allows users to view their account balance and deposit or withdraw money. To implement the required functionality, the servlets will have to coordinate their processes and share the data. For example, if a user directly tries to access an account servlet should be able to determine the user's login status, and it should redirect the user to the login page if he is not logged in. On the other hand, once a user logs in, login servlet should be able to share the USERD with account servlet so that account servlet can display the status of the account without asking for the USERD again. The Servlet API provides elegant ways to share data and to coordinate the servlet processes. We will discuss these ways in the following sections. 4. 8. 1. Sharing the data attribute scopes. Data is shared between the servlets using the rendezvous concept. One servlet puts the data in a well-known place, which acts as a container, and other servlets access the data from that place. These well-known containers are the Servlet request object, the HTTP session object, and the Servlet context object. All three objects provide a set attribute string name, object value method to put the data in the container, and an object getAttributeStringName method to access the data. Although data can be shared using any of these containers, there is a difference in the visibility of the data present in these containers. Simply put, objects shared using ServletRequest are accessible only for the life of a request. Objects shared using HTTP session are accessible only for the life of the session, and objects shared using Servlet context are accessible for the life of the web application. To understand this difference clearly, consider the following situations where we have different requirements for sharing the data. The banking application that we described earlier needs to provide credit reports for the users. So, we add a reporter servlet which, given a social security number SSN, can generate a credit report for any user. When a user asks for his credit report, account servlet should be able to retrieve the SSN and pass it on to reporter servlet. In this case, account servlet should be able to share the SSN with reporter servlet only for that request. Once the request is serviced, reporter servlet should not be able to access the SSN anymore. As described before, login servlet should be able to share the USERD with account servlet, but account servlet should be able to access only the USERD for the user whose request it is servicing. Further, it should be able to access it for as long as the user is logged in. All three servlets, login servlet, account servlet, and reporter servlet need to access the same database, and so driver class name, URL, username, and password should be shared with all the servlets all of the time. The three containers that we mentioned earlier help us in these situations. If we put an object in a javax.servlet ServletRequest object, it can be shared with any servlet that processes that request. We will see how to pass this request object around in section 4. 8. 2. If a servlet puts an object in a javax.servlet HTTP session object, it can be accessed by any servlet anytime but only while the servlet is servicing a request for the same client who put the object into the session, and only while that session is valid. We will learn about this in detail in Chapter 8, Session Management. If a servlet puts an object in the javaServlet context object, it can be accessed anytime by any servlet of the same web application. We will work with the servlet context object in Chapter 6, the servlet container model. All three interfaces provide the same set of three methods for setting and getting attributes, as shown in Table 4. 11. We will build a simple web application that uses these concepts in Section 4. 8. 3. Table 4. 11. The methods available in ServletRequest, HTTP session, and Servlet context for getting and setting attributes. Object getAttributeString This method returns the value mapped to this name or null if no such name exists. Enumeration getAttributeNames. This method returns an enumeration of strings for all the names that are available in this container. Void setAttributeString object value. The method adds the given name value pair to this container. If the name is already present, then the old value is removed. 4. 8. 2. Coordinating servlets using Request Dispatcher. Again, with respect to the banking application, if a user is not logged in, account servlet should forward the request to login servlet. Similarly, once a user enters her user ID, password, login servlet should forward the request to account servlet. The Servlet API includes the javax.servlet request dispatcher interface, which allows us to do this. It has the two methods shown in Table 4. 12. Table 4. 12 methods provided by request dispatcher for forwarding, including a request to, from another resource. Void forward ServletRequest ServletResponse. This method allows a servlet to process a request partially and then forward the request to another servlet for generating the final response. It can also be used to forward a request from one active resource, a servlet or a JSP page, to another resource servlet, JSP file, or HTML file on a server. This method can be called only if the response is not committed. Otherwise, it will throw an illegal state exception. Void includes ServletRequest ServletResponse. This method allows the contents of another resource to be included with the response being generated by the calling resource. Unlike forwarding, control is not permanently passed to another resource. Instead, it is passed temporarily so that the other resource can partially process the request, and then the including servlet JSP page can take over the request again and service it to completion. The included resource cannot set the headers or status code of the response. Attempts to do so are ignored. Note an important difference between Request Dispatcher, Forward, and HttpServletResponse. Send redirect, which we discussed in Section 4. Forward is that Request Dispatcher, Forward is completely handled on the server side, while HttpServletResponse, Send redirect, sends a redirect message to the browser. In that sense, Request Dispatcher, Forward is transparent to the browser, while HttpServletResponse, Send redirect is not. This sounds good, but how do we obtain a Request Dispatcher in the first place? Simple. Both javax.servlet context and javax.servlet have the method shown in Table 4. 13. Table 4. 13. The method in servlet context and servlet request for getting a request dispatcher. Public request dispatcher get request dispatcher string path. The path parameter is the path to the resource. For example, request get request dispatcher servlet account servlet. It will not accept a path outside the current web application. Besides the getRequestDispatcher method, the Servlet context interface also provides a getNameDispatcher method, which allows us to dispatch requests to a component by specifying its name as given in the deployment descriptor instead of a full URI path. There is an important difference between the getRequestDispatcher method of Servlet context and that of ServletRequest. You can pass a relative path to the getRequestDispatcher method of ServletRequest but not to the getRequestDispatcher method of Servlet context. For example, request getRequestDispatcher HTML copyright HTML is valid, and the getRequestDispatcher method of ServletRequest will evaluate the path relative to the path of the request. For the getRequestDispatcher method of Servlet context, the path parameter cannot be relative and must start with. This makes sense because ServletRequest has a current request path to evaluate the relative path while Servlet context does not. Note you cannot directly forward or include a request to a resource in another web application. To do this, you need to get a reference to the Servlet context of the other web application using this getServletContext getContextUriPath. Using this Servlet context reference, you can retrieve an appropriate request dispatcher object as usual. 4. 8. 3. Accessing request scoped attributes with request dispatcher. One important aspect of the new Servlet specification involves the ability of an included or forwarded servlet to access request information through attributes. The name of the attribute depends on whether request dispatcher, include or request dispatcher, forward was invoked. The attributes are listed in Table 4. 14. Table 4. 14 attributes available to included, forwarded servlets for obtaining information about the request. The values of these attributes provide the same information as the HttpServletRequest methods getRequestUri, getContextPath, getServletPath, getPathInfo, and getQueryString. They can be accessed with getAttribute just like regular request attributes. These values correspond to the parameters of the original request, without regard to further forwarding. For example, if a forwarded servlet invokes rec getServletPath, the result will be the same as if the Java servlet include servletPath attribute had been acquired with rec getAttribute javax servlet include ServletPath. Note these attributes can't be set if the request dispatcher was obtained with the getNameDispatcher method. 4. 8. 4. Putting it all together, a simple banking application. Let's build the banking application that we have been discussing, using two servlets, login servlet account servlet, login servlet. Listing 4. 9 contains the code for login servlet that verifies the user ID and password and forwards the request to account servlet. Listing 4. 9 login servlet. Java for a simple banking web application package. Chapter 4. Import Java. IO. Java. Util. Import javax. Servlet. Import javax. Servlet. HTTP. Public class login servlet extends HttpServlet hashtable users equal new hashtable. This method will be called if somebody types the URL for the servlet in the address field of the browser. Public void do get HttpServletRequest rec HttpServletResponse res throws servlet exception I exception do post rec res. This method retrieves the user and password, verifies them, and if valid, it forwards the request to account servlet. Otherwise, it forwards the request to the login page. Public void do post HttpServletRequest rec HttpServletResponse res throws servlet exception I exception string usert equal rec getParameter usert. string password equal rec, get parameter password. If USERT equal no password, equal no password, equals users, get USERT rec, set attribute USERT, Servlet context code equal get Servlet context, request dispatcher road equals CT, get request dispatcher, servlet, account servlet, RD, forward rec, res, return, else request dispatcher RD equal rec, get request dispatcher, login, HTML, RD, forward rec, res, return, initialize some userds and passwords public void init users, put in, AAA, users, put John, JJJ, users, put Mark, MMM. The logic of authenticating a user in the servlet in listing 4. Dyne is simple. We initialize a hash table to store some user IDs and passwords. In the doPost method, the servlet validates the credentials given by the user and forwards the request to either account servlet or to the login page. Observe the use of an absolute path used in the creation of request dispatcher for account servlet and the use of a relative path in the creation of request dispatcher for the login page. Login, HTML. To access our application, a user will go to the login page. This page will allow the user to enter her user ID and password. Listing 4. 10 contains the code for the login page. Listing 4. 10 login, HTML for capturing the username and password. Doctype HTML public. W3C. DTD HTML4. 0 transitional. EN. HTML, head, title. SCWCD example 1.3. Title, head, body. H3. Please enter your username and password to see your account statement. H3. P. Form action equal servlet. Login servlet method equal post. Usert. Input type equal text name equal usert. BR. BR. Password. Input type equal password name equal password. BR. BR. Input type equal submit value equal show statement. Form. Body. HTML. Account servlet. Listing 4. 11 contains the code for account servlet. Its job is to generate an HTML page that displays the user's account information. Listing 4. 11 account servlet. Java package chapter 4. Import Java. IO. Import Java. Util. Import javax. Servlet. Import javax. Servlet. HTTP. Public class account servlet extends HttpServlet hashtable data equal new hashtable. This method will be called if somebody types the URL for the servlet in the address field of the browser. Public void do get HttpServletRequest HttpServletResponse res throws javax. Servlet. Servlet exception, Java. IO. I exception do post rec, res. Public void do post HttpServletRequest HttpServletResponse res throws javax. Servlet. Servlet exception, Java. IO. I exception string usert equals string rec. Get attribute usert. If usert equal null, retrieve the data and generate the page dynamically. String records equals string data. Get usert. PrintWriter PW equal res. getWriter. PW. println. HTML. PW. println. Head. PW. println. Head. PW. println. Body. PW. println. H3. Account status for plus usert plus at the start of previous 3 months. H3. P. For int I equals 0. I. Records. Length. IPW. Print on records I plus. BR. PW. Println. Body. PW, println, HTML, else, no user ID, send login, HTML to the user, observe the use of relative path, request dispatcher road equal rec, get request dispatcher, login, HTML, or D, forward rec, res, initialize some data, public void init data, put in, new string 01, 01 2000 to 1000, 0001, 02 2000 to 1300, 0001, 03 2002, 900, 00, data, put John, new string 01, 01 2000 to 4500, 0001, 02 2000 to 2100, 0001, 03 2000 to 2600, 00, data, put Mark, new string 01, 01 2000 to 7800, 0001, 02 2000 to 5200, 0001, 03 2000 to 1900, 00. Running the application. We have provided the above examples on the Manning website. Just copy the chapter 04 directory from the website to the WEB-INF directory of your Tomcat installation. For example, if you have installed Tomcat to C, Jakarta Tomcat 5, 0, 25, copy the chapter 04 directory to C, Jakarta Tomcat 5, 0, 25. WEB-INF. Once you restart Tomcat, you can go to HTTP localhost 8080 chapter 04 login HTML. You should observe the following. If you enter an invalid user ID, password, you get the login page. If you enter a valid user ID, password, you get the statement page. You may also notice that the user needs to enter the user ID and password every time he tries to access account Servlet. This is indeed annoying. There should be some way for account Servlet to remember the user ID during the time in which it is interacting with the user. There is. That's where the concept of sessions comes into the picture. We will discuss sessions in detail in Chapter 8. 4.9 Summary. In this chapter, we discussed the basics of the servlet model. An HTTP servlet has methods, which can be overridden, that correspond to the HTTP methods of the request. The service HttpServletRequest, HttpServletResponse method of HttpServlet is responsible for calling the appropriate method on the servlet depending on the request. Using HttpServletRequest and HttpServletResponse, we learned how to create a dynamic response by analyzing the request. We also discussed the life cycle phases of a servlet, including loading, initializing, destroying, and unloading the servlet. The servlet request, HTTP session, and servlet context objects are the containers used to share data within the three scopes of a servlet: request, session, and application. Finally, we developed a small web application, in which we shared data between two servlets and coordinated their execution. You should now be ready to answer exam questions based on the HTTP methods get, post, and head and the methods of a servlet that correspond to these HTTP methods. You should be able to answer the questions based on the servlet lifecycle and the usage of servlets and related classes to retrieve request header information, form parameters, and text and binary streams. Finally, you should be able to answer questions based on attribute sharing using the request, session, and application scopes. In the next chapter, we will take a closer look at the structure of a web application, the deployment descriptor, and the way in which a request is mapped to a servlet. 4.10 Review questions. 1. Which method in the HttpServlet class services the HTTP POST request? Select 1. A do POST Servlet request, Servlet response. B do POST Servlet request, Servlet response. C service post HTTP Servlet request, HTTP Servlet response. D do post HTTP Servlet request, HttpServletResponse. Answer. D. Explanation. Remember that HttpServlet extends generic servlet and provides HTTPS PCIFIC functionality. Thus, all its methods take HttpServletRequest and HttpServletResponse objects as parameters. Also, the method names follow the standard Java naming convention. For example, the method for processing POST requests is doPost and not doPost. 2. Consider the following HTML page code. HTML. Body. A ref equal. Servlet. Hello Servlet. Post. A. Body. HTML. Which method of Hello Servlet will be invoked when the hyperlink displayed by the above page is clicked? Select 1. A do get. B do post. C do form. D do ref. E service get. Answer. A. Explanation. Don't get confused by the text post displayed by the hyperlink. A click on a hyperlink always generates an HTTP GET request, which is handled by the doGet method. You can generate a POST request through a hyperlink by using JavaScript. For example, HTML, script language equal JavaScript, function send post dummy form. Submit. Script, body, form name equal dummy form action equal. Servlet. Hello Servlet method equal post. Input type equal text name equal name, form, a ref equal on click equal JavaScript. Send post. Post. A. Body. HTML. This HTML code executes the JavaScript function sendPost whenever the hyperlink is clicked. This function submits the dummy form, causing a POST request to be sent. 3. Consider the following code for the doGet method. Public void doGet HttpServletRequest HttpServletResponse res PrintWriter out equal res. getWriter. Out. Println. HTML. Body. Hello. Body. HTML. 1 if rec. getParameterName null res. Send error HttpServletResponse. SC unauthorized. Which of the following lines can be inserted at 1 so that the above code does not throw any exception? Select 1. If res is sent. B if res is committed. C if res is done. D if res is flushed. E if res flush. Answer. B. Explanation. This question is based on the concept that the HttpServletResponse send error method throws an illegal state exception if the response has already been sent to the client. The servlet request is committed method checks whether or not the response is committed. 4. Which of the following lines would initialize the out variable for sending a Microsoft Word file to the browser? Select 1. A PrintWriter out equal response. getServlet output. B. PrintWriter out equal response. getPrintWriter. C. OutputStream out equal response. getWriter. D. PrintWriter out equal response. getOutputStream. E. OutputStream out equal response. getOutputStream. F. Servlet OutputStream out equal response. getServlet OutputStream. Answer. E. Explanation. For sending any data other than text, you need to get the OutputStream object. ServletResponse. getOutputStream returns an object of type ServletOutputStream, where ServletOutputStream extends OutputStream. 5. You need to send a GIF file to the browser. Which of the following lines should be called after or before a call to response? getOutputStream. Select 1. A response. setContentType image. GIF. Before. B. Response. setContentType image. GIF. After. C. Response. setDataType image. GIF. Before. D. Response. setDataType image. GIF. After. E. Response. setStreamType image. GIF. Before. F-response. Set stream type image. GIF. After. Answer. Explanation. You need to set the content type of the response using the servlet response. Set content type method before calling the servlet response. GetOutputStream method. 6. Consider the following HTML page code. HTML. Body. Form name equal data action equal. Servlet. Data servlet method equal post. Input type equal text name equal name. Input type equal submit name equal submit. Form. Body. HTML. Identify the two methods that can be used to retrieve the value of the name parameter when the form is submitted. A getParameterName. B getParameterValueName. C getParameterValuesName. D getParametersName. E getValueName. F getName. Answers. A and C explanation. ServletRequest provides two methods to retrieve input parameters. GetParameterName returns a string or null. GetParameterValuesName returns a string array containing all the values for the name parameter or null. Besides these two, ServletRequest also provides a getParameterNames method that returns an enumeration object of all the parameter names present in the request, or an empty enumeration if the request does not contain any parameter. 7. Which of the following methods would you use to retrieve header values from a request? Select 2. A getHeader of ServletRequest. B getHeader value of ServletRequest. C getHeader of HttpServletRequest. D getHeaders of ServletRequest. E getHeaders of HttpServletRequest. Answers. B and E explanation. Headers are a feature of the HTTP protocol. Thus, all the header-specific methods belong to HttpServletRequest. getHeader returns a string or null, while getHeaders returns an enumeration of all the values for that header or an empty enumeration. 8. Consider the following code. Public void do get HttpServletRequest rec. HttpServletResponse throws a exception if rec. GetParameter switch null. 1 else. Other code. Which of the following lines can be inserted at 1 so that the request is redirected to the collect info HTML page? Select 1 rec. Send redirect collect info HTML. B rec. Redirect collect info HTML. C res. Direct collect info HTML. D res. Send redirect collect info HTML. E this. Send redirect collect info HTML. F this. Send collect info HTML. Answer. D explanation. You can redirect the client to another resource using the HttpServletResponse. Send redirect method. 9. Consider the following code. Public void do get HttpServletRequest rec. HttpServletResponse HTTP session equal rec. Get session. Servlet context CTX equal this. Get servlet context. If rec. Get parameter usered. Equal null string usered equal rec. Get parameter usered. 1. You want the usered parameter to be available only to the requests that come from the same user. Which of the following lines would you insert at? 1. Select 1. A session. Set attribute usered. B rec. Set attribute usered. C CTX. Add attribute usered. D session. Add attribute usered. E this. Add parameter usered. F this. Set attribute usered. Answer. Explanation. Attributes stored in the session scope are available only for the requests from the same client. Attributes stored in the context scope are available for all the requests to the same web application from all the clients. Attributes stored in the request scope are available only for the request in which it is stored. 10. Which of the following lines would you use to include the output of data servlet into any other servlet? Select 1. A request dispatcher RD equal request. Get request dispatcher. Servlet. Data servlet. RD. Include request, response. B. Request dispatcher RD equal request. Get request dispatcher. Servlet. Data servlet. RD. Include response. C. Request dispatcher RD equal request. Get request dispatcher. RD. Include. Servlet. Data servlet, request, response. D. Request dispatcher RD equal request. Get request dispatcher. RD. Include. Servlet. Data servlet, response. E. Request dispatcher RD equal request. Get request dispatcher. RD. Include. Servlet. Data servlet. Answer. Explanation. To forward or include a request to another resource, first you need to get a request dispatcher object from either ServletRequest or Servlet context. Then you can call include or forward and pass the current request and response objects as parameters.